I remember last time I introduced you to data analysis, and of course, we're going to continue from there today. In the outline today, I'm going to briefly talk about some basic fundamentals, okay, as far as data analysis is concerned. And then I will walk you through what we call the four-step process. And after that, then I'm going to talk about applications. Before going into fundamentals, um, I want to have a recap on what we did on Wednesday. On Wednesday, I actually introduced you to model, how we normally use model to capture reality. And I told you, um, you know, when we want to understand our environment, we want to take a decision that we are not going to regret, we need information. We live in a world where before you can actually solve a problem, you need information to be able to solve a problem. And you know what? If you want to get this information, then you need to collect data. And that is the reason why researchers will call data as an essential ingredient in any investigation. Okay, give me 1 second. Okay, I think I have it here. So data, okay, they refer to data as essential ingredient in any investigation. So which means if I actually want to solve a problem, if I really want to understand what response to provide to practical problem, I need to collect data. And I told you the other time, the information that we're looking for is in the data set, but it's not readily available. Something needs to be done. Then we need to confront the data set with models. We got different kind of models. We need a proper statistical model to be able to extract the largest information in the data set. And because of that, that is the reason why we care about understanding different kind of statistical models we have around. Okay, let me tell you this. Every statistical model has a combination of a deterministic and a random component. And it is as a result of that, that is the reason why model can never be the same as reality. There's always going to be error. Okay, there's always going to be error. So today, when you look at statistical model, statistical models at times is expressed in terms of variables. I'm going to say that again. Statistical models is expressed in terms of variables, okay? And because with statistical model, we can actually understand the relationship among variables. For instance, maybe I want to know what is the relationship between a vaccination rate, okay, and infection rate of COVID. We can actually specify a model in terms of variables, and that is the reason where I want to start from today. We need some basic terminologies like variables, observational unit, and so on like that for us to be able to understand what we're doing. Now I'm going to start with the first terminology called the observational unit. When I say observational unit, I'm actually referring to an experimental unit to which treatment is applied. For instance, if I'm talking about the score of students, the experimental unit, the observational unit is actually students. If I want to talk about getting the blood pressure or getting the weight, the height in hospital, the observational unit will be patients. And let me tell you this, it is not all the time that the observational unit has to be persons. Observational unit could be countries. I may want to compare, if I happens to be a macroeconomist who want to compare the standard of living in countries, then countries become observational units. Is there anyone who need clarification on the understanding of observational unit? Is there anyone? You get that, right? Okay, now variables. When we say variables, of course, we're going to talk about variable because we live in a stochastic world. We live in a world where there's a variations. And when I talk about variable, a variable is anything that is liable to change. Okay, anything that is liable to change. That is what we call variable. Okay, and that was why I said the characteristics that we measured or recorded about each observational unit. If I come to you and I say, okay, can you tell me how much you spend maybe on phone in a week? You are the observational unit. What is measured is actually the amount you spend on phone, and that amount there is a variable. You know why it's a variable? Because you are likely going to spend different amount at different time. Okay. Now, when we now talk about variable, we got types of variable. I'm going to talk about two types of variable here. We have what we call the explanatory variable. We have what we call the response variable. Let me tell you this, when you are looking at the relationship, when your model is actually, if you're using a statistical model to study relationship among variables, you actually need to identify what is your response, what is your explanatory variable. And let me tell you the meaning of explanatory variable is a variable that can be manipulated, and you observe its effects on another variable. I'm going to say that again. A variable that can be manipulated and observe its effects on another variable is what we call explanatory variable. It has several names. We call it explanatory variable. We call it predictor. Okay, we call it independent. That's another name of explanatory variable. I'm going to give you an example of explanatory variable now. The amount spent on advertising. You can decide to change the amount you spend on advertising in a particular month. You could spend 1,000 on advertising, and you actually want to look at the effects on the volume of sales. In another month, you could decide to change it to $2,000. It means you are actually manipulating that variable. That's what we call explanatory variable. I'm going to go into a response variable now. We call it dependent variable. We call it an outcome variable. It's a variable that depends for its value on another variable. This variable here, it depends for its value on another variable. An example of that is the volume of sales. The volume of sales depends on the amount spent on advertising. And maybe probably those people in medicine may claim that the vaccination, the infection rate is going to go down if more people are, when they get vaccinated. They could argue that how, okay, we may want to look at the effects, like in economics, where they're going to say, okay, the higher the price, the lower the quantity demanded. Look at that, okay? It means when something goes down, the other one goes up, okay? So take a look at that. That's what we mean by response variable in your research. Okay, you need to be able to identify when you are using statistical model and you are studying relationship, you need to be able to identify what is my response and what is my predictor variable or what is my explanatory variable. Okay, I'm going to give you another example in politics. Um, if I know the percentage of votes received by a political party in the presidential election in 2012, okay, can I use that information to predict the percentage of votes that will be received by that same political party in the presidential election in 2016? Or if I have the knowledge of information about the percentage of votes received by maybe a Republican candidate or a Democratic candidate in 2020 in the United States, can I use that information to predict, what percentage of vote is going to be for 2024? Okay, so in that situation, you have variables that you're talking about. Okay, I want to give you more example of variables right now. So when you are given a kind of scenario or you have a research problem, how are you actually going to identify whether, how will you identify a response variable or the predictor variable from a given scenario? That's what I want to walk you through right now. Okay, I want to use a panda fertility treatment. A team of veterinarians want to compare the effectiveness of two fertility treatments for panda captivity. The two treatments are in vitro fertilization and male fertility medication. Okay, this experiment has one experiment. Now, when you take a look at this, we want to look at what is the explanatory variable here and what is the response. The explanatory variable here is basically the type of fertility. You want to say, what is the contribution? What is the effects of a particular variable? That if you're looking at the effect of a variable on another variable, that particular variable is a predictor variable, or we call it an explanatory. So right now, it is the type of fertility. When you look at the type of fertility that we have a vitro fertilization and male fertility medications. We actually want to say, what is it? What effect does it have on the fertility rate? The fertility rate is the response. Is there anyone who actually need clarification on how to identify the response variable or the explanatory variable from a given question? Is there anyone? Whether in person or online. Those of you online, can you confirm if you're hearing me? Can somebody confirm if you're hearing me clearly?
Yeah, we hear you.
Okay, I'm super excited to hear you are hearing me clearly. Thank you so much. And those of you here, you can hear me well, right? Is there anyone who is struggling with the way I talk? Please do not hide your feelings. You pay for the service. Is there anyone? And if you cannot tell me right now, you can send a message to me. It's okay, is that you talk so fast or you talk so slow, but I'm going to make sure I'm statistical in talking. Okay, so this is not a lecture. This is a party, and I want everyone to enjoy my party. Okay, now I'm going to go into another example right now. Okay, public speaking approaches. A public speaking teacher has developed a new lesson that she believes decreases student anxiety in public speaking situations more than the old lesson. Okay, now take a look at that. That was old lesson. Now we got a new lesson. Now we want to say, I told you the other time, we find ourselves in a world where we can never get satisfied with anything. We always always look for a way to improve. Now, that the intention of the person is developing a lesson that can actually decrease, okay, the anxiety. When people want to speak in public, some of the, like my daughter, when you ask my daughter to speak, it's going to be, I say, they're not going to, okay, if you want to talk, maybe you don't look at their faces, just be talking, stuff like that. Okay, she began an experimental test if a new lesson works better than the old lesson. Okay, public speaking students are randomly assigned to receive either the new or old lesson. Now, because of this, I'm going to walk you through different types of studies. There is observational studies. There is experimental study. Like if you take a look at this now, they say they randomly assign students into two different groups. A group will receive old lesson. Okay, another group will receive new lesson. But let me tell you this, when students are, when participants are randomly assigned to two different groups, it means any of the group can receive any of the students. You allow what I call the principle of randomization. Principle of randomization. I'm still going to talk about that. Okay, I'm still going to talk about the way participant has been partitioned into groups. Okay, when we take a look at this right now, of course, the explanatory variable will be the type of lesson received. But let me tell you this. A variable can be continuous or categorical. The explanatory variable here is categorical. Why do I say categorical? Because we have more than one level. We got two types of that. Okay, that's a categorical explanatory variable. That's a categorical explanatory variable. Okay, of course, the response variable is the anxiety level. Because at the end of the day, you're going to measure the anxiety level of students that receive old lesson and the anxiety level of students that receive new lesson. That's what you're going to measure at the end of the day. And that's a response. What are you trying to do? You're trying to look at the effect of the type of lesson on the anxiety. That's what you're trying to investigate. Okay. Oh, I like coffee. This is another example on coffee now. A researcher believes that the origin of beans used to make a cup of coffee affect hyperactivity. Look at that, the origin, okay, of where that, what they used to make coffee, okay, they believe that it affects hyperactivity, and they want to compare coffee from different regions, Africa, South America, and Mexico. What is the explanatory variable here? That would be the origin. And the explanatory variable here is categorical because it has more than one level. How many levels do we have here? Africa, South America, and Mexico. You got 3 levels. When the level of a variable is more than one, then that variable is categorical. I'm going to say that again. When a level of a variable is more than one, I'm going to write that down. So when a level of a variable is more than one, it is said to be categorical. It is categorical. Okay, I want you to take note of that. Okay, of course, the response variable would be the hyperactivity level. That will be the response variable. And you know what? The response variable can be continuous and can also be categorical. A variable can be continuous. A variable, whether response or explanatory, could be continuous, could be discrete, could be categorical. Okay, height and age. These are 2 different variables. A group of middle school students want to know if they can use height to predict age. Look at that. You want to use height to predict age, okay, which means the height is an explanatory variable and the age is going to be your response variable. And when they do that, they take a random sample of 50 people at their school, both students and teachers, and record each individual height and age. And of course, This is an observational study. Now, why is it an observational study? Because of this now, I will quickly differentiate between observational studies and experimental study. Okay, for you to be able to understand what we mean, for a study to be observational or to be experimental. Okay, I say it's an observational study. Of course, you know that, height is explanatory variable and age is the response. Age is what you want to predict, which is also an outcome variable. But you know what? We call this explanatory variable. And we call this observational study. And because of that, I want to distinguish between observational studies and experimental study. Okay, let me write that. Observational and design experimental study. Design experimental studies. Now, let me tell you the difference between the two. With observational study, we don't assign participants to different groups randomly. What we do, we merely observe. Imagine you are walking in the very busy street of the downtown Minneapolis, and you saw somebody who was asking people randomly. It was asking them question, and the question is, how many do you have pets? And the person said yes. How many pets do you have? And he's taking record of that, and he used that information, to decide whether it would make sense to have more pets stored in that particular area. That's an observational study. Okay, you do that, when you conduct survey, then that's an observational study. In observational study, you observe. You don't impose condition on the subject. You don't control variable. Okay, I'm going to give you this example. I'm going to remember now there was a sign. I don't know if you guys have heard about Science Daily. Who have heard about Science Daily? Okay, Science Daily, if you check their website, June 8, 2008, okay, they look at the effects of post traumatic post traumatic maybe disorder on the heart disease. Okay, on maybe the rate of heart disease among retired soldiers, the veterans. They really want to see what they did. Those soldiers that have a post-traumatic disorder, they observe, okay, whether they're going to have heart disease or not. And this is what happened. They actually observe two groups of veterans. Some has a disease, some have a post-traumatic disorder, and some do not have. And they come to the two groups, they observe them, whether they have the heart disease. That's an observational study. You know why it's an observational study? Because the researcher did not force the veteran to have a post-traumatic. They already have it. Some have it, some don't have it. That is why it is observational. But when we talk about experimental study, maybe I want to look at the effect of different diets. I'm going to tell you what I work on. In my bachelor project, I work on the effect of some selected, let me write it down, what I work on my bachelor project in 2007, where I work on the effect of some selected feats on the weight gaining ability of peaks. This is what I work on in my bachelor project. You know what I did? We actually use different kind of feed. Okay, we randomly assign pigs into three different diets. That's an experimental study because we have a control, of the situation. We control, the variable. Why are we doing that? Because we control variable to be able to isolate the effects of that on the response. We want to isolate the effect of, what the response is going to be when I do this. So this is what we call an experimental study. But you know what? Most of the time we don't go for experimental study because of the ethical issues, and it is very costly, to do. And most of the time, it's used to be observational, but only that the observational study is associational. It is not causation. Okay, which I'm still going to explain later. Okay, now there's another one. Okay, the tall grade boys tend to be taller than, the tall grade girls. If you take a look at this, it means you are looking at the effect of gender. Okay, because they are both in tall grade, but the difference between the two groups is that some are girls and some are boys. Okay, and so you are looking at the effect of gender on what? On height. Height is a response variable. So all what I'm trying to talk about is for you to be able to identify what is your variable, what is the nature of your variable, or is it explanatory variable, or is it response variable? You need to be able to identify that. Okay, I've talked about categorical and quantitative variables now. I told you the other time, the variables can be either be categorical when it has more than one level. But if it has only one level, then it is quantitative. Okay? And, I gave an example here. I said categorical variables are those that provide a grouping that may have no logical order or a logical order with inconsistent differences between groups. Okay, for instance, the difference between the first place and the second place in the race is not equivalent to the difference between the third place and the fourth. They are not the same. That's a difference between them. But the fact remains that first place is different from second place. So which is categorized. That's what we mean. And of course, the quantitative variable actually have numerical values with consistent intervals. So which we're still going to talk about. Okay, I think I gave more example on categorical variable. Names or labels with no logical order, or with a logical order but inconsistent differences, like rankings of university. Okay, or rankings of this and rankings of that. They're actually qualitative in nature and not quantitative. I want to tell you, like, when you look at zip code, if my zip code number is 55447 and the another person's zip code is 55449, the difference between the number does not make sense. It's just for labeling. It's just for labeling. That's it. Okay, so that's what we mean. Therefore, the quantitative variable, of course, you have a numerical values. Okay. A team of medical researchers weigh participant in kilogram. Of course, look at that, weight. Oh, weight is quantitative. It's not categorical. Though somebody can argue that you can make weight to be categorical by saying, okay, those who weigh between 5 to 10, those who weigh between 11 to whatever, this is categorical now. But weight on its own, if you don't talk about this, is quantitative. Okay? It's quantitative because it takes on numerical values with meaningful magnitude and equal intervals. Okay. Oh my God, I'm waiting for summer to come so that I like ice cream a lot. Okay. Now, favorite ice cream flavor. A teacher conducts a poll in a class. She asks a student if they would prefer chocolate, vanilla, or strawberry ice cream at their class party. They prefer ice cream flavor. Of course, because we're talking about, um, you know, different types of ice cream flavor, that make it categorical. Okay, that make it categorical. But categorical with no meaningful order. You know why there's no meaningful order? Can you look at it, in magnitude, the difference between the strawberry ice cream and vanilla? No, it's just like when you have a race, when you have the white, the African American, the Latinos. Can you find the difference? Can you say white minus African American? It doesn't make sense doing that. Okay, so that is without meaningful order of magnitude. We just use the level to distinguish a particular race from the other one. We are in a world that is full of variations. And I used to tell some people when they are fighting over something, I'm going to say, what make war to be beautiful is because of variation. Imagine the way you guys are sitting down beautiful now, because you know why you have different kind of clothes. Imagine if you wear the same clothes with the same color, it's not going to be colorful. You know that, because you wear different kind of color, different kind of shade, and that make the world to be beautiful. I see a lot of good things in variations. That's what I see. And that will make me to appreciate that. Oh my God, take a look at that. When I see somebody, oh, this is so beautiful. And I said, oh, this is more beautiful. Oh my God, this is another one. It's more beautiful. That is what I want to see. And that is a variation I will talk about. I used to tell people, variation does not come by accident. It is designed to be. And we have to live by it. Okay. Birth location, another example. A survey asks, on which continent were you born? Of course, continent, that's categorical. Okay. Now, a researcher want to know if dogs who are fed only canned food have different body mass indices, BMI, than dogs who are fed only hard food. Of course, we have two different types of food, right? And they collect BMI data from 50 dogs who eat only canned food and 50 dogs who eat only hard food. Of course, when I say, okay, the other time I was talking about observational unit, right? Another name for observational unit is cases. Cases. The cases here are the dogs. They are the observational units. We also call them experimental units. They are the unit that receive the treatment, a unit, the smallest unit to which treatment is applied. That's what we mean by that. Then we got two variables, type of food and BMI. But the type of food is explanatory variable. The BMI is a response. The type of food here is categorical. The BMI is quantitative because it does not have more than one level. Okay, before I go into the next objective of the day, is there anyone who need clarification? Is there anyone? If you guys are good, whether you're online or here, let me know. You good, right? Okay. If you are not enjoying my party, you need to tell me. Okay. Now, 4-step process. You know what I want to walk you through now? Now you understand the component of models. Models have variables, right? You know the different types of variable we have, right? And you know their nature. But the next thing we want to do now If we want to conduct a statistical analysis on data set using model, I'm going to say that again. You want to conduct statistical analysis on data set using model, then we got 4-step process, okay, that we're actually going to follow. If you want to do that, number one, we need to choose a form for the model. How do we choose a form for the model? We have different kind of models, different kind of statistical models. We have, as time goes on, you're going to hear me talking about linear regression model, where we're going to talk about logistic regression models. There are different kind of models around, but you know what? Before I can choose a model for my data, then it means I'm guided. I'm going to say that again. I'm being guided. I really understand, okay, when you are fitting a model, when you are suggesting a model, when you are choosing a form of a model for your data set, then it means you are already guided. You already understand on average, the relationship and what a functional form of the model is going to be. Let me remind you of what you have done before in high school. Of course, in high school, you've heard about linear function, right? Where you plotted the response against, the predictor, and you're going to see, this is a straight line. And even in high school, you've done something that has to do with a quadratic, right? Where you plot, you see a curve, right? We have different kind of models out there. Okay. Now, when you choose a form for the model, the next thing you're going to do, fit the model to the data set. You've already collected the data set. Now you want to fit a model for the data set. Fitting a model for the data set now actually means you are using the model on the data set. I'm actually going to walk you through that in this class, how we can fit a model to the data set. But let me tell you this. We always want to make sure we choose an appropriate model, okay, for the data set, because every selection starts with assumption. Okay, well, let us assume this model, but you know what? At the end of the day, we have a way to investigate whether the model we are choosing is appropriate or not. How do we tell? Take a look at this. By assessing how well the model describes the data, because we actually, there should be an agreement between a model and the data. If there is no agreement between them, then the model will not do the job. Because we expect the model to extract the largest percentage of information in the data set. I told you the other time, there's no perfect model. No model in the world can extract 100% information in the data set. I'm going to say that again. No model in the world can extract 100% of information in the data set. If you really want to assess a model, if you really want to investigate whether the model we have chosen, is doing the job, then we have a way to investigate that. Okay, and that is what we call model validation. We want to validate our model. What are we going to see? Do we have a model selection criteria? Do we have a criteria that will tell us how good is our model? Because if you really want to know whether the model is doing the job, the question you're going to ask yourself, how good is this model? Another question is, how wrong is this model? I'm going to say that again. How good is the model? How wrong? When I say how wrong is, I'm trying to investigate error. Because the more the error, then the more the model will be wrong. We know we can never do without error. But what are we trying to do? We're trying to minimize it. That's what we're trying to do. When you minimize error, you are closing the gap between model and reality. Because there's always going to be a gap. But only that we want the gap to be very, very, small. Okay. Now, after that, if the model is good, because we have a criteria to investigate that, then the last thing is we use the model to address the question that motivated collecting the data in the first place. There was a reason why you collected the data in the first place, because you actually want to answer a question. You can only use that, you can only use that if and only if the model is valid. And we have a test in statistics. And that's what we call diagnostic tests. So, why we investigate a model, we want to see whether the model is really doing the job or not. Okay, what makes a model good? There are generally two different things that we want from our statistical model. First, we want it to describe our data well. That's what we want. But let me tell you this. If a model does not describe our data well, if there's no agreement between a model and the data, there's no way the model will describe the data well. Okay? Okay, that is, we want to have it the lowest possible error. Of course, we cannot do without error. But we actually want to have the lowest possible error. We're going to be looking for the method that will be characterized with minimal error. That's what we want. Second, we want to generalize where to new data set. We find ourselves in a world where when we're doing research, we don't have resources to study the entire item in the population. We normally take sample, right? When you take a sample of data, if your model is good, we can actually use information from the few data set you've collected. We can generalize that on the entire population, which means using new set of data, the model can actually be used to do generalization. That's what we call statistical inference. I could remember the first time I came into the United States in 2013, I was to present my PhD work at the Central Michigan University in Pleasant in the state of Michigan. And I touched down in Austin, Texas airport. I was to connect to Michigan, and I asked one American, I said, "Oh, sorry, can you direct me to where I'm going to get my flight?" And the person said, "Okay, you're going to go that way." As I was going, I missed my way, and I asked another American, I said, can you direct me? And he helped me. What do you think I'm going to have in mind? Oh, Americans are nice. That's what I'm going to have in mind, because I'm using the observation of the few ones to generalize on the entire population. That is what we do in statistics. But what if somebody behaves badly to me first time, another person also I'm going to generalize too? Oh, maybe that is the way they are. Okay. Now it turns out that these two features can often be in conflict. They can be in conflict, and we're going to tell you in future how they can actually be in conflict. Now, I quickly want to go into applications. For instance, I think there was a time obesity rate in US and Canada, was at alarming rates. Let me write that down. Obesity. Okay. Obesity was an issue in the United States and Canada. And because of that, we want to look at the effect of financial incentives, how financial incentive can improve initial weight loss. Okay, maybe when you decide to say, okay, you're going to give people money, okay, or maybe that will help in improving on weight loss. So we examine whether financial incentive can improve weight loss maintenance, okay, and this is what happened. You give some people incentives, and this is the weight loss after, this is their weight after 4 months. And the other group, you did not give them, they didn't have any incentives, okay? And we have two different groups now, okay? One with incentives, the other one without. And what are we trying to do? We want to look at the effects of financial incentives on weight loss. Whether they have incentive or not, there's still going to be weight loss, but we actually want to say whether there's a significant difference between them. That's exactly what we want to see. Of course, you're going to do t-tests. You know, you've done t-tests before, right? So you're going to do t-tests. This is how you're going to do that in our incentive. I have the data set, control, I have the data set, then you do the t-dot test, right? The t-dot test of the incentive and the control, and we have this result. Now, when you take a look at this result, there are two things that are important to me on this result. You look at the p-value, okay? You know, when you look at the non-hypothesis is going to tell you there is no significant difference in the weight loss between the two groups, while the alternative hypothesis is going to say there is. Now, if I want to take a decision, I look at the p-value. I wanted to put this in down. When p-value is less than level of significance, the level of significance is alpha, which can be 0.05 or 0.01. When p-value is less than alpha, then you reject H naught. You know, rejecting H naught means there's a significant difference between the two groups. Now, take a look at the p-value that we have right now. The p-value is less than a 0.05 level of significance, and the conclusion here is that, you know, the weight loss, you know, in the two groups are statistically different. Take a look at that. Another thing you should pay attention to is the confidence interval. When a confidence interval included 0, there is no significant difference. But when the confidence interval does not include 0, then there is a significant difference. Of course, can you have a 0 between negative and negative? No. When your confidence interval is from negative to negative or positive to positive, then that means there's a significant difference. It is only when you have a confidence interval from negative to positive that you're going to say there is no significant difference. So right now, the confidence interval agree with the p-value. That is the end of the class today. But you know what? At the end of the week, this is the end of the week, I need you to send a message to me about, I needed to rate your understanding of what we did on Wednesday and what we did today. Rate that from 0 to 100. If you have less than 100, please include in your message what you need me to clarify on, and I'm going to reply your message. Make sure you stay safe and have a very beautiful day. My email. Yeah. You have my email, right? Okay. You're welcome. Yeah, those of you online, you're good, right? Okay. Thank you too. Yeah, thank you. Thank you. Have a good day. Yep. Thank you.